Thank you, Christian, and thank you, Gilles and Anders, for having us. Thank you for attending, of course. I will tell you something about our brand new Delft doublet with a promising scientific future. And I'm doing this on behalf of my team, of which I'm a part. Actually, it's quite a lot. The first time I sent my slides to Christian, I got an email back. Are you sure you can present 87 slides in 15 minutes? So I trimmed it down, and this is what's left of it. So, but if there's any questions or you feel I didn't touch on something, please approach me, and I can tell more. At least try. There you go. So let me first introduce the geothermal, the Dutch geothermal situation. Currently, there's about 40 operational geothermal doublets, and all of those are in horticulture, or as we call them, glass gardeners. And those people all use direct use geothermal, so that's non-electricity producing geothermal energy. But there's great ambitions. As you see in the top right, the Dutch government is aiming for 700 doublets by 2050, and that is equivalent to 25 new doublets a year. Every 2 weeks, a new doublet. That's a challenge, and that's what we, TU Delft, are trying to contribute to. And if we take the map of the Netherlands, you can see this is by TNO. The green spots are very high potential spots for geothermal energy with favorable geology and also nearby situated customers. As you see, the university I work for is right in the middle of such a good spot, and the 5 biggest cities, Amsterdam, Rotterdam, The Hague, Utrecht and Eindhoven, are all on these high potential spots, and this means that there's a high density amount of customers that can use district heating, that results in a certain price that I will not recalculate to NORCE, but that's equivalent to 80 euros or dollars a barrel, so that's competitive in some sense. Then on to our project, the campus project. Let me take this here. It's working now. Okay. Our project, it's one project with 2 goals. You see a schematic of our campus. First of all, it's energy. Our TU Delft wants to be carbon neutral by 2035, and a big part of that emission is heating, so there's a geothermal well for that. And knowledge, of course. We want to be present all the way from the design to the infrastructure to the entire lifetime to monitor and install infrastructure to monitor. And that's been done with a couple of companies, of which you know at least one, I assume. And those cooperate in a new company that will produce the energy. And TU Delft, of course, is part of that. And also TU Delft is owner of the knowledge part. And that's where I will mostly be talking on. First, we installed, a couple of years ago already, we installed 3 monitoring stations, 2 to 500 meters depth with geophones, which are continuously real-time listening to whatever we do in the subsurface, also during construction, and they will do during production as well. So that's let me emphasize, by the way, that all the data we gather is open source. So if you'd like to have access, that's possible, also for this kind of data. Next, we installed a geothermal doublet. That's what we did last year. And that's in place now. So that's a 2.3 kilometer deep doublet, 1.5 kilometers apart at the injection production point. And following up on that, we'd like to install seasonal storage. And we're currently drilling pilot wells for that. So that's not in place, but we're in an operational construction phase there. And on top of that, we are planning a deep monitoring borehole, and that's a very ambitious project that we aim to. Right in the middle, we want to drill a deep monitoring borehole, 4.5 kilometers through vertical, to to monitor the cold front, etc. But I'll get back to that. And this all ends up being the Delft Subsurface Urban Energy Laboratory, which short is DUSEL, or Diesel as you might like better. But we are working on that. The geological setting is way different than Norway. I knew that up front, but after all your presentations, I think it's even more different than I thought it is. At some points, our basement is at 15 or 16 kilometers, and on top of that is sediments. So in some sense, we are blessed, and sometimes we are cursed with the geology. So Delft is situated on top of the Pijnacker Graben. So the Graben is over there, and you see there's already, on the top, here's The Hague, here's Rotterdam. There's already a number of doublets, and the one in the middle is the one we installed. And if you take a look at the, it's early Cretaceous fluvial deltaic sandstone at about 2 to 2.3 kilometers depth at 80 degrees. And if we zoom into that, you see we drill the injector towards the deeper part of the Graben, of course, higher temperatures, and the injector still on the Graben side, but slightly more shallow. Some drilling well schematic for the enthusiasts. It was hard to fit in how in depth we wanted to go with this presentation. You see, the producer is a 3-section well completed with 7-inch wire-wrap screens at the bottom, and cased with 13 chrome casing, so very corrosion resistant because of the 1.08 brine that's down there at temperature. So that's very corrosive, and especially in the beginning, the Netherlands had geothermal industry had quite some issues, with corrosion and. I wouldn't say bad well design, but compromised well design. And a fiber optic cable hanging in there, which is research, which I'll come back to. And also the injector, it's a 2-section design with perforations at the bottom. And again, those perforations have not been done yet, but the well test in the producer was good enough to know that our reservoir was suited. A bit on the drilling. There's some promotional shots on the right. It was a Huisman Lock 400 with 400 tons force. We've been batch drilling our wells, so we first did the top sections with 800 meters water-based mud with the skidding in between. And after that, we switched the fluid system to oil-based mud, and we completed both wells, again, with a skidding of 7 meters, with a total drilling of 7,500. And quick math, that's a bit more than we anticipated, because we did some sidetracking. And what's nice to see, next to this building, there's the old electricity and power plant of the TU Delft. And originally that was built as a coal-fired plant. In the 70s, it switched to a second-generation gas-fired plant to feed the district heating. And now we're installing the third-generation geothermal part. So that's also positive for district heating as a whole. That's an issue in the Netherlands. But you see district heating... the source of your district heating can be changed along the go, and therefore I'd say it's always a good investment to do so, even though some forces might be against. That's the drilling part. That's not the drilling part because there were difficulties. We were too fast there. You see, this is the injector and a schematic of what we've been doing. The black line is our first attempt, so to say, where we got all the way into the reservoir but ended up having hole stability issues. So we attack it under a 45-degree angle. As I said, it's not that consolidated as it is here, our formations. And one of our formations started caving in, and we saw, cavings. And we decided to do a sidetrack because we weren't able to get the casing in. We did a sidetrack as one, all the way to the reservoir again, and unfortunately again we saw cavings, and we did a second sidetrack which was successful. But this resulted in more meterage and more cost, of course. And one of the questions is, how can oil and gas help geothermal? I wouldn't say that we were inexperienced, but there was definitely, I would argue, skill would help. If we would have been doing more wells, or we would have been more experienced in some sense, these are things that might be prevented in the future. You see that our sidetrack moved, the green one is the planned one, the blue one is the sidetrack. We moved slightly towards the producer, which results in a slightly lower lifetime. It still is way over 30 years, so at least anticipated, but you cannot move too far because you actually shorten your reservoir, of course. Then on to the research. We had 4 main research topics, which is coring, open hole logging, fiber optics, and high frequency cutting sampling. I'll stress on the coring because that's most visual as well. If there's any questions later on, again, please approach me. So this is the log with a core hanging right there. This is the coring bit was a 4-inch coring bit, or at least internal. So we got 86 meters of 4-inch cores from the producer reservoir. So that's at depth. That's the Delft sandstone. Almost all of them are sequential. So that's a very big part of the top of our reservoir is in our basement currently, and I'll touch on that. This is interesting. This is the top of the first core with still some imprints of the PDC bit that was used to get there. So that's something that the PDC bit manufacturer really liked and then published because they were proud of the clean marking. The Delft sandstone, our pay zone, so to say. And this is Tara, one of our students and employees. Who were a lot of students were also involved and got experience of a rig site. And how often do you see a rig site on a walking or cycling distance of the faculty you're actually taught how to do so? This is within our faculty as well. We have a medical scanner where we have scanned all the cores we achieved. This is the medical scanner, which is a good resolution, but can be better. We also have a high resolution scanner, which takes a lot longer, so we haven't done that yet. But as you see, for instance, some siderite. This is our first core, and you can fairly good see density differences, but also induced fractures or present fractures. This is something that you don't want to see, which can result in jamming while coring, which I won't bother you with, but which caused us a pain at least. And as I just said, this is our well, the Del GT01, the producer well, and our cores. And you see we managed to core quite a significant part of the top of the reservoir, which is interesting in the future because we will be able to actively monitor the production and see the actual zone where it comes from. Fiber optics, will not talk too much on that, apart from the fact that it will be hanging from the ESP, which on the one hand makes it vulnerable, on the other hand makes it replaceable. So there will be temperature and pressure nodes in there hanging from the bottom. It's a Halliburton fiber optic, so that must be good. And we are going to install this one in the near future. Some facts. The entire system is expected to have a flow of up to 400 cubic meters an hour, which is more than 100 liters per second, through this one production well and, of course, the injector well as well. That's quite high flow rates, but manageable, and that will result in an expected power output of 25 megawatt thermal. Again, which is quite high, also for Dutch geothermal systems. And some more, and what we also like, and what is sometimes forgotten, is that since we are, the Netherlands is planning to do a lot of urban geothermal, this was a showcase. This is a very, as you saw on the video, very urban environment with a relatively small rig. We had a lot of visitors that we could explain and show what it beholds to have a drilling rig in your backyard. Future work, that's why I'm here actually. This is what we are planning to do, but let me take out two. The high temperature aquifer thermal energy storage. That's somebody else named HEAT. I'm not sure what the international abbreviation is. We tend to use this one. We are planning to store seasonal or at least summer heat produced by the geothermal well that we will not use in a shallow formation about 200 meters deep. And again, we are drilling pilot holes right now. This is the Push It project, very interesting, which greatly increase your winter production rate. And on top of that, the deep monitoring borehole, which will be drilled within 5 years. Near vertical, as I said, up to 4,500 meters through vertical. We don't expect it to be flowing at this moment. We expect to install fiber optics, etc. But if there's any ideas, I'll talk on that in a minute. I don't have a minute. We will be doing continuous scoring again, and this time not under an angle. We found out that the 45 angle of attack degrees was hard. So I'm really excited about this, and a lot of my colleagues are as well. And that's why, let me first get to this. We are organizing a workshop where we'd like input from academics and companies to see how we can get most out of this well. The application deadline is tomorrow, but I'm sure we can arrange something. That's nice. And wrapping up, these are all our partners, and of course it was a team effort within TU Delft as well. So there's a lot of people behind me or in front of me. Thank you very much. Yeah.
Yeah, impressed that you made 41 slides in 50 minutes, and you had 87. Yeah.
So there's some backup.
Yeah, so he has some backup. Very nice. I've seen them. So, any questions? Yep. Atle?
Yeah. So some of it is over 1 darcy. Yeah. And sandstone again. Jill?
Yeah. Any input from the offset wells, geothermal doublet, regarding the well stability issues? Did they report? Did you have access to that data?
Well, looking back, there was so the offset wells are these. Looking back, there have been some issues with this, and in the same formation as we encountered, but we decided to go with oil-based mud instead of water-based, and thought that would. Well, there were a lot of mitigational measures, but in the end, it proved not to be enough. So that's a lesson learned and something to take with us in the future. Okay, on the first one, there's geonodes or geophones in the monitoring wells, if that's what you're asking. Not in 2 of those. In one other, I believe there's a chance to still install it. So we're, considering. But of course, it's very costly. And on the maintenance, which maintenance? On the entire... Okay, well... I should ballpark this because I'm on the knowledge side and not the energy side, so we don't do maintenance on that one. But I believe that it's mostly capex, so it's very low.
Just one from me. I saw the picture with the rig in an urban environment. Mm-hmm. Myself, been working on designing ram rigs and so on, and it's fun to see it in urban. But what about social acceptance? Did you see any reactions, some negative reactions of having a big rig in a city like this? And
well, the worst reactions actually were to the fact that we are cooperating with Shell. Not so much the rig itself. Okay. So academics are usually very credible within society. So that helped. And luckily, there was not too much houses nearby. The biggest issue was an exam hall, which we put a huge soundproof barrier in front, and that was most of the people reacted very enthusiastically.
Yeah.
Yep.
But it was electrically operated, or was it?
Yeah.
Okay,
But it was electric top drive, so you hear that, of course. Hydraulic top drive, but still. Yeah.
But you had the generators, diesel, or did you connect to the?
It was
to
grid powered.
Grid power. Yeah.
Yeah.
Okay. Yeah. Okay, Malte, one more.
Did you monitor connectivity between the wells?
No, because we haven't perforated the injector yet. But since we know it's a fluvial system, and there's in the same Delft sandstone, there's a number of systems already. We know connectivity. We expect connectivity to be fairly good. Yeah.
But no stimulation at all? Or?
Not needed. No. No.
Thank you.